So what we can do is we can think about something. There is a thought to listen to and think about. Imagine if I tell you, I know in an array, I know sum of these three elements. This sum is known. Can you tell me sum of remaining elements in the array? In order to do that, you will say, if you tell me the total sum, if total sum is known and left sum is known, then obviously right sum can be easily calculated. It will be nothing but total sum minus sum, right? So that is much better proposition to deal with. What we can do is we can manage with just the left sum array and total sum. So what we can do when we are building the left sum, we also remember the total sum. So left sum array and the total sum. So let's say how we build that left sum is, it's 0, 1, 2, 3, 4, 5, 6. So let's say till 0, we know left sum is 0. Now for 1, the left sum will be this plus 0th element, which is 4. Now the left sum is 7. Now the left sum is 8. Then the left sum is 10. Then it is 17. Then 17, 9, 26. After that, if you add the last element in total sum, this sum plus last element gives us the total sum. So we know total sum is 27, left sum array is this. So we have come to a point where we have used one array and we have also calculated total sum. Now what we can do is we can start going over this array. Let's say we reach the first element, its left sum is 0. Let's look at what the right sum is. Now if you see, the right sum will be calculated based on total sum minus current element that is there, current element that, and minus left sum. This will give me the remaining sum, because what we are doing is essentially, if you notice, we have the left sum of this element. So what we are doing is total sum we know, subtract this element and subtract left sum that we have, we will get the right sum. So this at 0th index may not make much sense. Let's look at the index 2. So at index 2, if you look at, if you know the total sum, we are looking for only right sum. So what we need to do is from total sum, we need to subtract 2 first, because right does not include 2. And we also need to subtract the left sum, only then we get the right sum. So using this formula, if we loop over this left sum array once again, at every index what we do, total sum minus current element of the array and left sum from this sub array for that index. If we keep doing this in one loop, if we go over, at any index where ls is equal to right s, left sum is equal to right sum, that's where we say we have found the answer. So if you look at in this approach, we have reduced our loops to two loops. First loop to build this and calculate sum, and second loop to validate. So time complexity that we have got now is 2n. Space complexity we have reduced from 2n to n. Now we are using only one array, right? So this is our approach 3. We have optimized this solution. Now if you talk about one more approach, you ideally do not even require the left sum array. We can even cut down this space complexity to big of 1. If you want to think about that solution, pause the video and you can do that. If you are not able to think of that solution, then you can always come back, resume this discussion. This trick that we are discussing in this problem, this is applicable to many more problems that we are going to see as more questions of the day on our group. So pause here and try to see, can you do it without this array? You still need left sum, you still need right sum. Right sum can be calculated from the left sum. Now what you have to think about is, how do I calculate left sum for every index without needing an array?